Welcome everyone who is connected for the Bhp Tailings Challenge Demo Day. My name is Sebastián Burgos, Corporate Business Associate at Fundacion Chile, and I'm going to be the host for this event. After a 6-month process, we are very pleased to have reached this stage, where you will finally meet the results and technologies that selected teams of the proof of concept stage have developed to repurpose copper tailings in a sustainable way. Let me just remind you that Bhp Tailings Challenge is an initiative that we have launched in 2020 together with Fundacion Chile through its Open Innovation Program Expande, and with the purpose of identifying the most innovative companies, startups, consortia, research centers, and universities to help transform fresh tailings and create innovative business models. After the call, we received a total of 154 applications from 19 countries, where 10 companies and consortia were selected to advance to the proof of concept stage. Today, there are 9 and not 10 teams presenting, since during the proof of concept stage, one of the teams decided not to continue, but we have 9 amazing teams presenting their solutions today. And before we start, I want to emphasize that this is probably one of the most important initiatives of this type that has been carried out, if not the most important. And we have no doubt that the entire mining industry is watching what happens here today. To be even more part of this, we invite you to follow the live coverage on the expanded social media with the hashtag Tails Challenge. To begin with, I would like to introduce you to Carlos Avila, Asset President Joint Venture at Bhp, who is connecting with us to give us some opening remarks. Carlos.
Thank you, Sebastián, and good morning or good afternoon, everyone. And thank you for attending, this session. The Bhp Tailings Challenge is an international call event that seeks to contribute to a sustainable economy, able to create and implement marketable solutions. The purpose of this challenge is to identify solutions to repurpose copper tailings as part of a feasibility business model. Given the current context and challenges, we need to find new ways of doing things, moving us toward a future in which industry, environment, and society converge, generating a virtuous and collaborative ecosystem. In this sense, the mining industry is making a great contribution in promoting innovative solutions for the efficient use of natural resources and the way to minimize and mitigate the environmental impacts that the activity could generate. We know we have an important role to play in building technical and innovative capabilities to deliver value to our business, the mining industry, and the communities we are a part of. We are convinced that we can advance in the development of a safer, more sustainable, and more productive mining industry. To achieve this goal, we firmly believe that collaboration and multidisciplinary work are the foundation for the faster and further progress in response to these challenges. To be successful, the teams has been asked to provide a comprehensive solution from tailings to end client, to stabilize the element most commonly present in copper tailings, and to propose the new products, materials, solutions that will come out of the tailings with an attractive business model that avoids environmental and social impact. As a sponsor of this challenge, I would like to thank the commitment of all those who have participated in leading this challenge during its different stages. Bhp, Antamina, and Fundacion Chile team who have made this challenge a complete success, even though the constraints and difficulties imposed by the COVID pandemic during the last 2 years. Because the great effort and the great commitments, please receive my recognition and deeply appreciation. Thank you, Sebastián.
Thanks, Carlos, for those welcoming words. Now it's time to introduce Marcos Culca, CEO at Fundacion Chile, who also wanted to be here to give you some welcome words.
Welcome everyone to Bhp Tailings Challenge Demo Day. We are living in a more complex, dynamic, and ambiguous world that challenges us every day to be more resilient and creative. One of those complex challenges we are facing in the world is climate change, or what we call it climate crisis. We have checked the phenomena at every COP and IPCC reports, besides the droughts, temperature changes, floods, etc. Of course, mining is not an exception of this phenomena. Today, the mining sector is striving to become completely sustainable with a better use of water, waste treatment, renewable energies, among many others. The mining sector, based on its key role in the new economy, not only copper as an indispensable raw material, but also to the relevance it does have in the world, should be an engine of new models of sustainable growth. Bhp Tailings Challenge is an example of that critical contribution that innovation, entrepreneurship, and the use of technology can play to move towards a more circular economy, even enabling the development of new industries that were born from a problem and transformed into a solution, like the reuse of copper tailings raw materials. In this line, BHP has set out some objectives to make significant progress in reducing, reusing, and recycling its industrial waste. That's when Fundacion Chile was contacted through the Open Innovation Platform in Mining, Expande, to launch the BHP Tailings Challenge. Through a global open call, the most innovative companies, startups, consortiums, research centers, and universities were invited to help transform fresh tailings and create new business models and marketable solutions. The contest, launched on June 16 of 2020, was divided in 4 phases or stages: the open call, the proof of concept, pilot, and finally the on-site industrial pilot. Those phases have been designed to reduce technological uncertainty while keeping options open for disruptive ideas to move forward and demonstrate their application's viability. Today the challenge is in the proof of concept stage, where the 9 selected teams among more than 150 applications from 19 countries have been validating for 9 months their solutions at the laboratory level. And today we are very excited to learn from each team today at the demo day the results that everyone has reached so far and see who moves to the next phase. Of the 9 teams, a maximum of 2 will go through a pilot test in a controlled environment for 18 months, a stage in which they will receive $300,000 so that they can prove that their processes operate in an integrated manner, are feasible to scale to industrial level, and its value proposition is commercially viable. The last instance and results of this stage will be known at the final demo day to be held in July 2023, where the winner or winners will receive $8.6 million to launch an industrial pilot, but that will be in situ. As Fundación Chile, we are honored to be part of this innovative process with BHP that can lead the way how we face many challenging problems through open innovation and corporate venture, 2 backbones of what we are undertaking at Fundación Chile through Expande and Chile Global Venture. Again, thanks to BHP for the possibility, and the best luck to all contestants. Have a nice day. Bye.
Thanks, Marcos. To continue, I would like to leave you with a message from the Chilean Undersecretary of Mining, Billy Kracht, who wanted to join us to give his vision on the importance of moving towards a more sustainable development for mining.
Hola, les quiero enviar un saludo en este Demo Day del Bhp Tailings Challenge desde el Ministerio de Minería y la Subsecretaría de Minería. Quisiera partir por relevar la importancia que tiene para nosotros el generar condiciones para transitar hacia un desarrollo sostenible de la industria minera en un contexto de cambio climático. Vemos cómo la lucha contra el cambio climático, en el caso de la actividad minera, impone desafíos en términos de generar o producir minerales y metales de bajas emisiones para su posterior uso en la transición energética. Ahora, eso no puede hacer que perdamos de vista la reducción de impactos locales, es decir, este desafío de reducir las emisiones de CO2 para poder acotar el impacto global que tienen estas emisiones, no puede hacer que nosotros dejemos de prestar atención a los impactos locales. En ese sentido, creo que iniciativas como la que nos convoca hoy, el Bhp Tailings Challenge, apunta justamente en esa dirección, la dirección correcta en términos de reducir tanto como sea posible los impactos locales, y en este caso en un tema tan importante como es el impacto asociado a la disposición de relaves. Yo quisiera saludar en esta oportunidad a los 9 equipos que han llegado hasta esta etapa del proceso. Sé que son equipos que vienen de diversos lugares del mundo. Hay chilenos como representantes de otros países del mundo. Espero que tengan mucho éxito en esta actividad, y les cuento que para nosotros es una actividad de la mayor importancia. Estamos muy interesados en el desarrollo de esta iniciativa y vamos a seguir muy de cerca los próximos pasos. Espero que la actividad sea un éxito y espero también que nos podamos encontrar prontamente.
Thank you, Undersecretary, for that message and for being part of this demo day. And now, it's the moment to start with the pitches round. Today, each team will have 5 minutes to present the solutions they have been working on for repurposing copper tailings. To begin with, we invite Andrew Harley from America's Tailings, Inc.
Thank you, Sebastian. Appreciate the opportunity to participate in this incredibly important work. Our work is a collaboration between America's Tailings, Inc., that has the mission to find sustainable uses for mine waste, and our technology partner, Advanced Materials Processing, Inc., which is working on ways to develop biomineral fertilizers. Looking at extracting nutrient value to provide beneficial use for mine tailings, supporting dam management, support on climate initiatives, while supporting the physical and economic health of the local community. The overall process involves combining an organic biomass with microbes that selectively release the nutrient value within the mineral framework of the tailings, providing a well-balanced, nutrient-rich fertilizer for local consumption and for export. While there is excellent work on using microbes to regulate the release of nutrients from organic sources, the microbial release of micronutrients from these tailings is the key in producing a high-value product. And there is certainly a growing demand for producing these mineral-rich fertilizers as a means of fortifying food. If these minerals aren't in the soil, they can't get into the food. The bench-scale work was undertaken at the same time as a rise in fertilizer prices and global supply chain issues during COVID, especially as production of fertilizers is concentrated in the Northern Hemisphere. This is further exacerbated by the Ukrainian conflict and sanctions on Russian goods, including fertilizer, where Russia accounts for 15% of nitrogenous fertilizers and 17% of global potash fertilizers. All indications is that the demand for fertilizer, including biomineral fertilizers, will increase due to increased populations, demand diets, as well as shrinking agricultural land, combined with a rapid increase in sustainable and regenerative agricultural practices focused at local food supply and security. The bench scale testing was undertaken with 3 different biomass sources and 3 tailing batches. Site levels in the supernatant, the process required dewatered tailings as feedstock. The finished product produced a significant carbon source, a good primary nutrients in nitrogen, phosphorus, and potassium, secondary nutrients such as calcium, and adequate micronutrients within the range of most crops. Environmentally, the mineral concentrations are not likely to pose an environmental risk, although further testing is proposed in the next phase. These products can fit into a broader sustainability of waste management and fertilizer production through the adoption of a circular economy, enhancing local employment and business opportunities, establishing a post-mining economy. In addition to local food production, the products can also be used for reclamation, restoration, and carbon offset projects. The adoption of biomineral fertilizers can also produce Scope 3 carbon offsets for both mine closure and community agricultural products. Healthy soils are also a prerequisite to achieve multiple sustainable development goals related to economic metrics, food security, health and well-being, environmental initiatives, and climate action. In the event of moving on to the next phase, We're looking at doing further lab work and evaluating the environmental risk and agronomic effectiveness on a much larger volume of material. And we'll also expand to include plant growth trials to evaluate yield and metal uptake, both nutritionally and from a potentially metal toxicity standpoint. Again, we want to thank BHP for the opportunity to be doing this work, and look forward to supporting BHP's commitment to developing a sustainable future. Thank you.
Thank you, Andrew, for the presentation. And now I would like to invite Abraham Jalvo from Auxilium Technology.
Hi, my name is Abe Jalwood, and we'll be presenting today the Untitled Tailings solution by Auxilium Technology Group in collaboration with Metso Autotech for the Bhp Tailings Challenge. The focus of our company is to maximize value from waste streams using sustainable solutions. Our primary target is to assist mining companies use tailings to achieve net zero. We have developed a modular approach called Entail. Entail can process legacy and fresh tailings. It does not interfere with upstream mining operations. We're a young company formed in 2020 based in Tucson, Arizona, as a spinoff of the University of Arizona. We also collaborate with the Critical Materials Institute as well as Idaho National Lab. Of note, one of our technologies has been awarded the prestigious R&D 100 Award in October of 2021. We have selected the San Javier Underground Mining Lab site in the town of Sahuarita, Arizona, managed by Department of Mining and Geological Engineering of the University of Arizona, as our proving grounds to showcase our solutions. Our Auxilium core team members include Daniel Valenzuela, our project manager, Kathy Arnold, our Director of Sustainability, Jehan Lee, our Director of Extractive Metallurgy, Artie Broad, our Director of Engineering, Momo Mayes, Director of Advanced Materials, Don Gervasio, Director of Energy Projects, Ariane Overwater, our Social License Advisor, Perry Lee, Tom Bowles, and other advisors as members of our team, in addition to Dr. Richard Dixon and Carl Tabara from the Metso Autotech team. Our approach has several advantages, including being modular, versatile, scalable, and compatible. The process leaves no waste at the end of the cycle and is replicable across different mining sites. Currently, our road to deployment includes several key steps, including piloting, design of pre-engineered modules, strategic partnerships, market analysis, offtake agreements prior to final full-scale deployment. Highlights from both our laboratory and techno-economic analysis have led to several key metrics, including 300 kilograms of CO2 for every ton of cement produced, 14 cubic meters of water saved per square meter covered by our HexLink smart platform system, and an overall IRR of around 20%. In terms of our products, there are different anticipated outcomes, such as ferric sulfate, sulfuric acid in Module 1, metals, rare earth elements, and other critical elements in Module 2, purified water, green hydrogen, and other energy products in Module 3, and our Entail and Geofoam products in Module 4 that can be used for insulation, cement additives, fill, and even as a precursor for the production of ultra-pure silica. During this stage, we were able to perform several step tests to validate our technologies for this case study. These include testing that were in products that were prototyped and different experimental validations. From an engineering aspect, we developed flow diagrams, met some simulations, and we devised a feasible financial model. In addition to this, in our market study, we performed customer discovery, developed partnerships, and identification of product off-taking relationships. As a final stage of the POC, we were able to refine our piloting strategy and define objectives, producing a very strong revenue model. As a justification to proposal analysis, we have collected data to validate our hypotheses. These include uprating of sulfide content to produce a high-quality concentrate. This concentrate was subject to a biometallurgical approach that yielded several products of value. The processed water was purified into potable drinking water. The treated tailings product was made into a geofoam, cellular concrete, and tests for cement, fill, and replacement were also performed. The end products were made to match commercially available products in the market and also validated by external testing facilities. On behalf of Auxilium Technology Group, we appreciate the kind efforts of BHP, the expanded team, and Fundacion Chile. Thank you for the opportunity to present today.
Thank you, Abraham. To continue, please welcome Michael Ingerson from the Circular Mine Consortium.
Hi, everyone. I just need to check that I'm unmuted. Sorry. Hi, everyone. I'm Michael Ingleson, Team Project Coordinator and Joint Co-Founder of Circular Mine Consortium with Charles Villiers, and it is our pleasure to be presenting our work in the Bhp Tailings Challenge Proof of Concept phase. Our vision of a tailings storage facility, transforming waste into valuable resources. The Circular Mine Consortium includes BRGM and Vito, both European leaders in recycling, Australian mining know-how of Mincor and Mech Solutions, and soil remediation experts, Soil Cyclers. This combines a unique mix of researchers, engineers, marketers with experience in cleaning, identifying value in mine waste, and project delivery. We cover all aspects from extraction, sorting, testing, transforming, marketing, and selling. Our team is robust with a passion to make zero mine waste a reality. Following a careful analysis, testing of the tailings, market research, each member identified risks and opportunities from the samples delivered to their respective laboratories. These findings were compared to the local conditions to identify market opportunities for repurposing of the tailings, to remove the largest volume of tailings and create a sustainable business. Revenue streams exist from processing the tailings, the minerals and metals extracted, construction products produced, carbon economy, water recovery, and topsoil supply. We work with locals, remove risk, and reduce emissions. The Circular Mine Consortium is a group of environmental businesses who fell in love with this challenge. We were very proud of our benchtop testing results and their ability to completely change the sustainability across the entire mining industry. We demonstrated that we could make tailings waste safe, so it no longer needed to be stored in tailings dams. We demonstrated that we could extract value from the tailings in the form of additional metal recovery, production of construction products, and also in the carbon economy, being approximately 10% of the revenue per annum for the particular tailings samples. We've demonstrated that we can turn the tailings into a fertile topsoil and use them to grow vegetables, creating a whole new agriculture and agroforestry industry for the communities around the mine site. Collectively, we have a strong track record across our technology components, project implementation, and a good appreciation of social values and impacts on communities. We transform mine waste into a resource for construction and agricultural sectors using an innovative bioleaching process to decontaminate and extract the remaining metals through the production of construction materials using carbonation technologies, and then ameliorate and remediate soils to the highest environmental standards. The team has the tools and expertise to scale up our process to industrial scale. Our flow sheet is mature and low risk. It is also flexible and can be adapted to process different tailings feedstock. We can remove the need for tailings dams. There is no waste in our process. We can process all tailings starting with a quantity of 1 million tonnes per annum and increasing from there. Our proposal is to move forward to an industrial implementation in 3 steps to achieve an initial commercial operation. Each step would further refine the initial test work, engage with stakeholders, and prepare for the next phase. We understand for approximately the same cost of BHP depositing and maintaining tailings facilities, that for potentially less than this, we can help BHP completely change sustainability of the mining industry. A future where tailings waste is recycled and reused, creating happier communities, better environmental outcomes. We look forward to the opportunity to work with BHP and help make zero mine waste a reality. Thank you, BHP, for the opportunity. Circular Mine Consortium team, BRGM, Vito, Soil Cyclers, Mincor, MX Solutions, for their commitment to the project, and further information on the Circular Mine Consortium, please contact Michael Ingwersen. Thank you.
Thanks, Michael, for your pitch. Now it's the turn of Jonathan Engelhardt from Recomine.
Okay, hi everybody. My name is Jonathan, and I'm hoping that you see me well and you see the presentation well. Yeah, as I said already, my name is Jonathan. I'm presenting the Recomine concept here in the Bhp Tailings Challenge. And Recomine basically focused on working on 3 different kind of Recomine products. The first is like adsorbents. Here we produced schwertmanite, and we did this by bioleaching pyrites. This schwertmanite is actually suitable as an adsorbent in passive water treatment. It adsorbs arsenates, which is commonly known as the most common pollutant in mine waters, but it also works as a pigment in colors. And here we work together with corporates from the chemical industry. We also focused on producing fine aggregates, so non-magnetic aggregates, which could be suitable in substituting silica aggregates in mortar and concrete, but that could also work in backfilling on construction sites. Finally, we also focused on industry minerals, and here we focused on crude garnet sands in order to produce water filter media and abrasives that could work in steel finishing and water jet cutting. So the Recomine concept is basically working in 3 modules. The first one is dealing with basically processing the tailings as we receive them from BHP with starting a sulfide separation. The sulfide concentrates either undergo bioleaching processes or they go into roasting processes. The roast product, the calcine, is a ferric sulfate that can be added to the leaching process in order to produce the schwertmanite that I explained earlier. Residual silicic slurry material here is going into the next module where we conduct a magnetic and a solid liquid separation. The magnetic fractions are then basically separated for a crude garnet sand, and the non-magnetic fraction is the one that is suitable for fine aggregates in construction industry. Finishing with the solid liquid separation, we produce water residues. These underwent water reclamation techniques, mainly membrane techniques, and ended up in process and domestic water. Just shortly to present the team, ourselves coming from Helmholtz Institute in Freiburg for research technology, we did the coordination and the flotation. Our colleagues from the SMI in Chile did the life cycle assessment, the social aspect. Our partner company Geos from Germany did the schwertmanite production. And now you see 4 different institutes here, all coming from the Technical University of Mining in Freiberg. And they did the solid liquid magnetic separation, the sulfide roasting, the calcine characterization, and the water reclamation. Having a look at the results, I'll first introduce you to the flotation. Here you see basically the outcome of the flotation, sulfur flotation that we conducted. You see in the concentrates, this big block of sulfides here, which covers more than 64% actually. And you see that the tailings, they are virtually free of sulfides. These tailings then underwent the magnetic separation, and you basically see here our main product, which is the crude garnet sand. And you could see by tuning very sensitively here the magnetic separation, we achieved a product of more than 94% garnet in a crude garnet sand, which is number 2. Number 4 here is actually the other product, which is virtually free of any magnetic minerals. And this is the other product ready for the construction industry. Concentrates over here went into the schwertmanite production. You see here 2 examples of schwertmanite, and we reached a maximum pyrite turnover of 78% from the pyrite. And we also showed that the schwertmanite is actually capable of adsorbing arsenates in passive water treatment. Our continuation is focused on working together with our partner company UVRFIA. They have a highly adjustable, fantastic pilot facility shown here on the right-hand side, where we could conduct our pilot scale testing in bigger scale. But we also want to continue to client and partner acquisition for the products. We have started here already pretty successfully, but we want to continue. And we want these partners to support us in product development. Our hypothesis in doing this is that the shredmonite is actually applicable also in mine water, and that the refinement of the crude garnet is economically viable. And last hypothesis is that the aggregates, that they are applicable in concrete production and in backfilling. To conclude, we showed an effective shredmonite production from the material that we received from BHP. We showed that we can do these non-magnetic fine aggregates for construction materials. We produced crude garnet sand, and we showed a concept ready for piloting. And overall, this was possible by linking modern industry partner with companies and institutions from environmental and resource technologies by involving also the society aspects. And with this, I'd like to thank colleagues from Expande and from Fundacion Chile, and especially from BHP, for having us and for having me today, and for the work of the last few months. Thank you.
Thanks, Jonathan, for your presentation. To continue, we invite Mauricio Villagran from Untitled Consortium.
Hello, everybody. Do you hear me? I hope you hear me well. Can you see my presentation right now? Well, hello, everyone. My name is Mauricio Villagran from UCC University, and it's a pleasure to be presenting today. On behalf of the Untitled Consortium, I would like to begin this presentation by thanking BHP and Tamina Fundacion Chile for the opportunity to be part of this technological challenge. It was and continues to be the beginning of what we hope will be a fruitful endeavor that will contribute significantly to adding value in mining's operation. Untitled Consortium is made up of 4 regional, not based in Santiago, Chilean companies with specific skills and capabilities to accomplish the challenge presented by our proposal. This is not a mystery tale, so I would like to start telling you our main achievement during this process. The main focus of our research was to look for quick ways to revalue tailings. Activities focused on using simple and well-known technologies to lower cost. Our results showed low mineral grades and low cementitious potential. With little leftover material, an attempt was made to achieve a cementitious product with attractive tailing reuse rates. Commercial dosages were achieved with 30% replacement of aggregates with tailings, and the development of product presented good mechanical, environmental, and durability characteristics. The research process allowed us to develop a prospective methodology that can be applied to any type of tailings. And we proposed the creation of a technological-based service company that seeks the revaluation of tailings for cementitious products. The methodology developed during the challenge allowed us to perform a fairly detailed characterization of the potential use of tailing for value extraction. The methodology was implemented in cascade form, maintaining the criterion of going from the simplest to the most complex, in order to increase the possibility of industrial implementation of the application that we propose. However, limitations in the volume of tailing available and the heterogeneity of the tailing prevent us from conducting a more exhaustive research for solutions. As presented in the methodology, tailings and tailings mortar specimen were subject to a variety of tests to determine the characteristics and potential. Among the most important, we can mention tests to detect the grades of the material, pozzolanic potential of the tailings, mechanical tests of the specimen, mineralogical characterization, leaching potential, permeability test, etc. In general terms, our analysis of results show low head grades, low pozzolanic reactivity, high variability in mechanical properties, very low permeability in the specimens, low leaching risk, and low chemical reaction. Many of these points were already mentioned in the main achievement slide. So in conclusion, for the proof of concept stage, from our perspective, tailings are not entirely favorable for use as a replacement for cement alone, or valuable mineral extraction. The mechanical feasibility of the massive use of tailing material in cementitious matrices is verified, obtaining mechanical behaviors superior to certain type of concrete with commercial values. The methodology proposed by the project offers a simple and effective process for assessing the reuse of the revaluation potential for any type of tailing, for both valuable extraction and application of cement products. Due to the ambiguous results obtained in the proof of concept stage, we decided to approach our proposal with two parallel paths. On the one hand, to give an answer to the tailings delivered by BHP from Antamina mine. On the other hand, to create a technological service company oriented to the search for value in kind of tailings. We call this company CEMTAIL Lab. For the first path, we propose the creation of a pilot plant that will quantify the great certainty of mineral recovery rates using MVC technology. Next, we propose to reuse the tailing in the construction of pavers, for which we believe the best solution is to work with local strategic partners who are already developing precast concrete products. I know that my pitch is, I think, is a bit long, so I will skip one. From the CEMTAIL Lab characteristic, what we think is create a new company with a very low risk, low initial investment, development of a demonstration pilot plant for the pavers, building capacity for research and innovation with tailings. The company will born as a university spin-off. We will leverage funds, public and private, to develop facilities and generate a joint service offering with MVC to address abandoned or inactive tailings dams. In this sense, this is a diagram that shows how we conceive the strategic alliance between MVC and CEMTAIL Lab. And the idea is that both companies generate value to the tailings at different stages of the process. And this business model can be implemented in any type of mine and existing tailing dams. In order to finish my presentation, I would like to share a thought with you. The real challenge we have in front of us to reuse tailing lies in building capacity in the industry to add value to tailings to the development of a multiplicity of applications, which together will reduce the volume of tailing. Thank you for your attention.
Thank you, Mauricio, for your pitch. Now is the turn of Claudia Eugenin from Pontificia Universidad Católica de Chile.
Hello, everyone. Thank you for being here. We are T2CM Tailing to Construction Materials, and today I will show you the results we obtained during the proof of concept within the Bhp Tailings Challenge. Our team is made up of three main parts. Management part made up of three main managers, a multidisciplinary scientific core, and of course our laboratory and development team, without which this would have been possible. And since we are attacking a complex and worldwide problem, we required a combination between world-class research and world-class industry leaders, which is why we partnered up with a number of companies from the construction materials sector, certification and advisory, engineering, etc. So obviously we're all aware of the tailings dam problem. We also identified a construction material problem, a gravel or a aggregate shortage problem. And so we saw an opportunity to hit two birds with one stone. Speaking of tailings passive and the construction materials shortage, and our project attacks those two problems. So why do we think we are a good fit for this challenge? Because we are from Chile and we have lived with a local problem that the tailings dams bring to our country because it is a mining country. So we think that we should use a local solution, but that however has worldwide effects because as we know, this is a worldwide problem. So our solution is the following: to give value to mine tailings by converting them into construction materials for sustainable infrastructure. And our project is by design adaptable to the variability inside tailings, making it applicable to any mining operation and also any type of tailings. Our process is a refining process that takes the fresh tailings, or it could also be deposited tailings, and extracts the things that would not be good for construction materials, and then turns them into viable construction materials. So during the proof of concept, we achieved a number of things. We achieved a prototype of cement paste with 20% replacement with tailings. We achieved artificial aggregate made with 100% alkaline activated tailings, which are also known as geopolymers. And we also obtained a printable concrete paste with 50% cement replacement. And I also want to say that the proof of concept results met our expectations and are replicable and validated through experimental protocols. The experiments were designed with defined input variables and response variables, and our protocols ensure repeatability and representability. These are some of the applications for the products that we achieved during the proof of concept. The cement paste could be used in any type of concrete. The artificial aggregate, which is the one that uses the most volume of tailings, could be used for landfills, for road filling. And the printable concrete, even if it is a surging technology, it could also be used for that. So our business plan is what you see on the screen. Our income would be divided between the metal recovery, the income we get from the aggregates, and also the tailings opportunity cost that we would obtain for taking the tailings that would otherwise present a cost for the mine operation. Our cost would be divided between the different treatment plants that we would use, and our production would be mainly aggregate. As I said before, that is the product that uses the most volume of the tailings. Our partners have supported us in the estimations and during the whole process of the proof of concept. So I would like to thank them for their help, and also say that our project, or the main core characteristic, is sustainability. We never want to forget the environmental and social impact, the responsible waste management, community management, etc. And as a conclusion, just to say that our motto is to make mine tailings fine tailings, and our project is an elegant solution to reduce tailing risk and liability and increase in safety and social value. And again, our project is adaptable to handle tailing variability over time or operation. So our invitation is to pave the road towards circular mining and construction together. Thank you very much for your time.
Thank you, Claudia. To continue, please welcome Douglas Aitken from the Solar Tailings Transformation Consortium.
Excellent, thank you. Good afternoon, good evening, good morning, depending upon where you're joining us from. Pleasure to be here, and thank you to Expande, Fundacion Chile, and Bhp for developing, supporting, and coordinating the Tailings Challenge program. I'm representing the Solar Tailings Transformation team led by the University of Queensland and the Sustainable Minerals Institute's International Center of Excellence in Chile in partnership with IMDIA, Aguasol, and Censo. Our concept uses solar power to convert tailings to glassy materials, flexible use pellets, together with a high level of water recovery. The development of our concept was based on addressing the critical challenges of tailings globally, the sheer volume of tailings production, the high water content of tailings, the limited inherent value of the material, their isolation and distance to cities generally, and the heterogeneity of the material. Through our concept, we aim to address each of these challenges. We look to nature in the challenge, specifically volcanic processes that produce lapulae, the molten droplets of lava that are ejected and hardened after cooling. The final pellets are tough and have been used in construction for thousands of years. So we wanted to replicate this process, but how? Our team is located in a part of the world with the highest solar irradiation, where there's also an abundance of tailings facilities. We believe that the complementarity has huge potential. So the concept we designed uses 2 stages to apply concentrated solar energy to first evaporate and condense the water fraction of the tailings, and then transform the dry tailings through ultra-high temperatures to inert pellets and another fraction to glassy materials. So the main end products of the process are water and pellets. The water can be used for industrial uses, agriculture. the pellets for construction, road building, or landscaping. And the process can also produce glassy materials such as ceramics, heat, and there's the option to remove high valuable minerals if they exist in the tailings. So we tested the concept in the first stage of the challenge. We wanted to determine the percentage water recovery that we could achieve. We wanted to test the feasibility of using simulated concentrated solar power to melt the tailings and produce agglomerates. And we wanted to check if we could sinter the agglomerated pellets at high temperatures. So what did we find? Using the evaporator condenser column system, we recovered 95% of the initial water content. We were able to melt the tailings and produce stable glassy materials at around 1,330 degrees using a conventional oven and then also with the concentrated solar simulator. We produced sintered briquettes from the dried materials, although we found that the mechanical strength of these briquettes to be quite low. But we also produced the agglomerated pellets using a cold bonding technique, and we were able to sinter them at high temperatures, but again, the mechanical properties were found to be quite weak. So what worked? We were able to achieve a high reduction of water content and removal of the water. We were able to melt the tailings using the solar simulator. We were able to produce a stable glassy end product, and we were able to agglomerate the dried tailings into briquettes and pellets. What needs to be worked on? The water quality issues that we found with the recovered water. We need to find a way to achieve agglomeration of the dry tailings particles around the melted tailings fraction, and also improve the sintering process to achieve the required stability. So what we're planning to do now is revise the process stream by including a pre-processing stage to desulfurize the tailings material, and we're in conversations with one of the other teams who have been part of the challenge. We're looking to use an alternative evaporation and condensation technology to improve the water recovery, and we want to test bonding options to improve the stability of the final pellets. So we're looking to work with a facility that has high solar irradiation potential, and we need to test the suitability of the end products in local markets as well for products such as glass, ceramics, pellets, and water. I mentioned at the start that we want to address the critical challenges of tailings, the high volume, the high water content, the isolation of facilities, and the complexity of the tailings material. Our concept is designed so that it can treat large volumes of tailings of differing characteristics. It's circular and it's focused on reusing all parts of the tailings material. It's based on renewable energy technologies and therefore low in carbon emissions. And it has a focus on developing local economies through flexible end-use products. So we believe that this flexibility and the sustainable approach will allow our concept to be a part of the solution to the global tailings challenge. Thank you very much.
Thank you, Douglas, for the presentation. Now I would like to invite Sami Kara from the University of New South Wales.
Good morning, everyone. My name is Sami Kara. I'll be giving this presentation on behalf of UNSW Consortium. Our consortium consists of UNSW Sydney, UNSW Newcastle, several industrial organizations and non-government organizations. Our solution is structured around a circular economy, as well as coupled with a digital twin to design, operate, and control future tailing management solutions. The proof of concept stage, we have proposed several deliverables. The first one is the identification of the tailings content. Outcome 2 is looking into recovery of water, copper, gold, molybdenum, and silver. The third outcome was looking into potential repurposing of the tailings, and finally looking into development of potential market and the management of water, energy, and associated environmental footprint. The flow diagram of our solution constructed around 3 loops. The first loop is the treated water, and the second loop is about extraction of precious materials, and the third loop about repurposing of the tailings. Based on these 3 loops, we have tested 3 scenarios. Scenario 1 consists of loop 1 and loop 3, and the final outcome is construction material and recycled water for agricultural use. Scenario 2 involves all 3 loops, and the final outcome of the scenario 2 is copper, construction material and recycled water for agricultural use. And the scenario 3 also involves all 3 loops, but the water actually recovery is further processed to grade 1, and the outcome is copper, construction material and recycled water for urban use. For the loop 1, our results indicate that the overall 75% water reduction in the existing Bay of Tailings dam can be achieved. For loop 2, reprocessing results suggest that the NOVA cell technology we have used could achieve 12% recovery of both the fine and coarse particle in the sample with a 60% copper recovery. More than 30% of the copper and manganese extraction is possible when the size is fine and the degree of liberation is sufficient and the leaching duration is more than 6 hours. For the repurposing, the results shows that the treated copper tailings can replace conventional supplementary cementitious materials such as fly ash, and treatments double the amorphous content and increase the reactivity of copper tailings. Based on these, we looked into several business models and potential markets, and our results indicate that the water, copper, and cementitious material recovery is not viable in and of itself due to operating costs. A reduction of 7% in the tailing maintenance cost would lead to positive project net present value for all scenarios. Our concluding remarks, tailings reprocessing and repurposing are technologically viable to produce end products based on using our primary revenue and cost assumption over 10 years period. The discounted cash flow analysis provided a negative net present value for all scenarios. Considering natural gas is the main driver, replacing natural gas with solar PV and induction heating will be a more sustainable and cost-effective option. Even though using renewable energy option increase the net present value, still the net present value of the project still remains. Our solutions provide significant reduction in the ongoing cost of management and maintaining the existing tailing. At $1 per year per ton of tailings, and assuming 570 million tons per year, a positive net present value is generated when the annual cost reduction in ongoing tailings management is 7%. Our finding indicates that the strategy of extended producer responsibility and the extended battery limits to include upstream mining operations are necessary to have an economically and environmental solution. This is the end of my presentation. I thank you for your attention.
Thank you, Sami, for your presentation. And to end with the pitches round, we would like to invite João Cerqueira from Universidad de Valparaíso.
Thank you, Sebastián. Hi, everyone. My name is João Cerqueira. I'm honored to be here to present the work carried out by our team, which are made up of members from 3 universities: Ociel Cofré, myself, Karim Chauán, Cristian Oyanedel, and Tomás Katz from Universidad de Valparaíso, Chile, Domingo Cantero, José Manuel Gómez, Gemma Cabrera, and Martín Jamírez from Universidad de Cádiz, Spain, and Edgardo Donati from Universidad Nacional de La Plata, Argentina, who, as a whole, have experience in several projects associated to mining, process, and environmental engineering. As a context, this proposal was made taking into consideration the green hydrogen initiatives that have been promoted worldwide in recent years, and the extended producer responsibility, in which containers and packagings are one of the residues that producers must take care in terms of environmental impact, either by reusing, recycling, reduce, or recover. In terms of market, we estimate the potential nitrogen production from 50 megatons a year of tailings with an average of 8% of iron oxide content to be of 12,550 tons per year of hydrogen, or the equivalent to 417 gigawatt-hour per year of energy. On the other hand, in relation to mineral paper, the potential market corresponds to 21 million tons per year in Latin America, or between 44 and 59 million tons per year worldwide, if we consider only 30% of its market. Considering all the above, the resulted industrial proposal corresponds to this main process scheme presented in here, where tailings are firstly treated as to produce green hydrogen by a thermochemical water splitting, Afterwards, the remaining minerals will be processed in order to solubilize the anionic metals, after which the insoluble fraction will be separated and processed into mineral paper with some polymer addition, and the liquid fraction will be pH neutralized and go through a reverse osmosis. As to verify the feasibility of this proposal, three main tests were performed during the proof of concept stage: hydrogen production from tailings, the feasibility of tailings bioleaching in order to reduce their metal content, and finally, to develop mineral paper and verify its inequity through bioassays. The first picture corresponds to the machine that had to be constructed specifically for this work, which allowed the production of hydrogen from tailings. In the middle, we can observe a graph obtained during one of the hydrogen production tests, from which a sample was taken for 18 minutes and was analyzed by an independent laboratory. The results indicated that for each kilogram of tailings, a quantity of 0.33 grams of hydrogen was produced. On the lower section, a photograph of the produced mineral paper samples can be seen, which were then used to test for both earthworm and seed germination ecotoxicological assays. The lower middle graph shows the values obtained for seed germination, showing no significant differences in reference to a control. On the other hand, from the production assays performed, for each kilogram of tailings, a total of 0.635 kilograms of mineral paper can be obtained, containing 20% of polymer, in accordance with its commercial counterpart. From the previous results, we show that on one hand, tailings can be used to produce hydrogen from water, and on the other hand, the obtained mineral paper did not present detectable ecotoxicological effects. In terms of replicability of this process so that it could be used with tailings from other sites, three conditions should be observed: availability of clean energy supply, the presence of metallic compounds that can be oxidized, and the availability of tailings with a low concentration of heavy metals. Otherwise, a more complex process will have to be implemented, thus increasing the production costs. In relation to sustainability, we can indicate that in terms of waste generation, the production of a reject flow from reverse osmosis, nonetheless, these flows still haven't been discarded as a possible byproduct, and other materials like lubricants, membranes, paints, among others. In terms of environmental impacts, we estimate as a negative one the generation of the aforementioned rejection stream, and as a positive one the tailings transformation into a commercial product. For social impacts, we highlight the use of local employment in the improvement of the local community's quality of life. Thank you for your attention and for this opportunity presented by BHP.
Thank you so much, Joao, and to all the companies that presented today. There is no doubt that the decision is tough, since all your solutions are very good and really innovative. Now that we have had the opportunity to see all the participants, in a few more minutes, we will know who the winners are. In the meantime, we invite you to watch a recap video of the proof of concept stage.
En BHP, reconocemos que la sustentabilidad es la forma en que las empresas necesitan operar si quieren ser competitivas y productivas en un futuro cercano. Es por eso que el año 2020, y con el propósito de contribuir a una economía más sustentable, que integre aspectos sociales y también aspectos medioambientales, es que hizo el lanzamiento de su programa Bhp Tailings Challenge.
Durante 6 meses, los equipos seleccionados trabajaron de cerca con el equipo de Bhp y Antamina, un joint venture propiedad de Bhp, Glencore, Teck y Mitsubishi, validando en sus laboratorios las soluciones más promisorias del mundo en la transformación de relaves.
Okay, and now to announce the teams selected that will pass to the next stage, where they can perform an integrated closed-loop pilot test in a controlled environment, we invite Claudia Cooper, VP Sustainability and External Affairs of Antamina.
Thank you, and hello to everybody. The evaluation of the Tailings Challenge Proof of Concept was a complex process in which a diverse group of BHP specialists reviewed the final reports of each of the 9 competing teams and had also one-on-one meetings with them to provide feedback and prepare them for their presentation to the jury. This generated the technical inputs that were used by the jury, formed by the following people: Carlos Avila, Ingrid Oyarzún, and Javier Rangel, in front of whom the teams presented their results, proposals, and vision for the BHP Tailings Challenge. A technical and economic review of the viability of implementation in the asset in question was carried out in order to make this decision. As you have seen, the proposals were very diverse and of very high quality, making this decision very difficult. Although all the proposals could have been implemented in different assets, we selected the teams based not only in the location, but also on the scope, performance, sustainability, scalability, business, and engineering. We will now move on to the pilot under controllable environment stage. In this phase, we will seek to integrate the technologies and generate the necessary information to be able to award the grant prize of $8.6 million that will finance an industrial pilot on site that we hope will mark the beginning of the tailings transformation. Each team that has been selected for the next stage will receive a 300,000 grant from BHP to continue its development. We hope that these resources, as well as the final award and tailings industry transformation opportunity, will also attract global investors to support these teams in making mining a more sustainable industry. Now comes what everybody is waiting for. The teams that will move on to the controlled environment pilot stage. The teams that are selected to advance to the next stage are: the first team is America's Tailings Inc. And the second team to advance is Auxilium Technology Group. Congratulations.
Congratulations, Auxilium Technology and America's Tailings, Abraham, Andrew. The selected teams for the pilot test stage. And of course, thank you to all the teams who got to this phase. At Fundación Chile and BHP, we are very, very happy about the work and effort each team has put into creating innovative business models for repurposing copper tailings. Let's briefly hear from the finalists. Andrew, how are you with the decision?
Oh, Sebastian, thank you. We are overwhelmed, with the opportunity to expand this. I think not only is the mining industry, going through, working towards sustainability and developing in new ways that are sustainable and and obviously benefit to society. I think we're seeing the same things in agriculture as well. And I think the two can, meld well together and develop these new sustainability areas. There's a lot of challenges, not just in resource and development, but in agricultural production as well. And really appreciate the opportunity to be furthering the, the work we've done thus far. Thank you.
Thank you. And Abraham, what can you tell us?
Yeah, well, first of all, we're very fortunate to be part of this challenge. It's been a pleasure since the beginning, and also probably one of the biggest opportunities, and also from a technical point of view, but also commercial aspect. We expect this project to impulse the tailings repurposing industry at a global scale. I just would like to take this opportunity to thank the whole Auxilium team. I'm also Richard Dixon from Metso Autotech, as well as the BHP, Expande, and also Fundacion Chile for this opportunity.
Great. Thank you both, and congratulations once again. And now To see what's coming next, we invite Ingrid Oyersun, Head of Sustainability Innovation at BHP.
Thank you, Sebastián, and first of all, congratulations to all who reached this stage, especially to the winners as well. And as you know, at BHP, this initiative is a contribution to the global mining industry, and we really hope this will be the beginning of the development of multiple technologies for repurposing tailings, which is today a transversal challenge for the industry. We are very pleased with the work and results that selected teams have achieved during this stage, where they have validated their hypothesis and obtained finished potential product with a high technological level. This proved that the decision of BHP to invest resources in a project such as a tailing challenge has given good results and represents an opportunity for all the mining industry to reduce tailings at a global level. During the next stage, Auxilium, an American tailings company, will perform an integrated closed-loop pilot under controllable environment. Expected results are laboratory test results demonstrating the repurposing of tailings into a new material, business model, and market analysis can help us. And this is a potential market, exists a potential market that could absorb the new product and proposal for scaling to an industrial location. We will support American Tailings, an Auxilium company, with the delivery of tailing samples to execute the new stage, and also provide masterclass support from technical and commercial experts, as well as fundraising activities to help teams obtain additional funding for the next stage and visit to laboratories. All this in order to obtain the support necessary to bring this stage to a successful outcome. By the end of the pilot in the controlled environment stage, participants must present the result in detail. This consists in, first of all, a feasibility study for the implementation of an on-site pilot plant. Secondly, a business plan to demonstrate technological and economic feasibility of the proposed project. And finally, a proposed strategy for implementing a full-scale facility to repurpose tailings. All of these will address the objective of the challenge and make it technically and economically feasible and also attractive from an investment perspective. And finally, congratulations again for all of the participants, and thanks, Sebastián, for facilitating this conversation.
Thank you very much, Ingrid. And with this, we are ending this demo day. We would like to thank all who have connected today, and we invite you to stay tuned for the next steps of the Bhp Tailings Challenge at www.tailingschallenge.com. Have a nice evening.